Hi everyone. So in this video, I will show you how to create your local search app using DeepSeek as an LLM, Ollama that permits to run the LLM locally, LlamaIndex for all the RAG orchestration part, and Streamlit to build the UI. So here I will show you what we will have at the end. After that, I will go through different steps to have this as a result. So in this RAG app, I will start with browse file. In this case, I will upload a survey on LLMs. So here we have our file upload, and we see that we have ready to chat here, so we can ask our model to answer question about this paper. So as it's a survey about LLMs, let's ask the question, what are LLMs? Wissam. As you see here is the reasoning part. So if we go quickly through the reasoning and the answer, so here we see that the model is understanding our query. Okay, so I need to figure out what LLMs are based on the context provided, because here the contexts are different parts of the paper. There is a lot about how LLMs are used as agents. Here is talking about techniques like React and Dira, putting it all together. Once the thinking part is done, we have LLMs, which stands for large language models, are advanced machine learning models designed to understand and generate human language, and so on. So here we have the answer. As you see here, guys, we have a result, a search app where we ask any question about our data. So here I loaded a PDF file, but you can load many files that you use to ask your LLM about. And it's important to keep in mind that all these can be run locally thanks to Ollama, and for free thanks to open source LLMs like DeepSeek. Let's now see what is going on behind the scenes. So here also it's to be mentioned that I'm presenting and running everything on lightning.ai platform to run everything, but you can run everything locally on your machines. So first things first, here is the global architecture of what is running behind the scenes. So we have our custom knowledge base. In our case, it was the PDF file that we upload in the beginning. After that, we apply chunking on these documents. Chunking is actually splitting these documents on chunks or smaller paragraphs, which results in a set of small chunks. This is done in the code by using a simple directory reader or a loader, to which we give the directory that contains our PDF files, and we use this loader to load data. These resulting chunks need to be converted into embeddings, which are vector representations of text. To do so, we need to load a embedding model. In this case, we use this model from Hugging Face. Once the chunks are converted, we store them in what we call a vector store. And this is the backbone of our search app, because all these vectors, so the chunks, so these documents will be stored in this vector store. And every query of users will be used to search the most similar chunks, the most similar to the query, or the most relevant chunks to answer to the user query. Like it's presented here, we have a query and we have the most similar documents that will be used to answer this query. This is done in the code by using vector store index, where we index our documents, and we will use the embedding model that we already defined to embed these documents in the vector store. Once the documents are indexed in the vector store, we define what we call our query engine, which is actually the vector store called index here, used as a query engine. And if you notice here, guys, we have the similarity top k equals to 4. It means that we return the 4 most relevant documents to answer to the question, as we see here. Now we define the prompt. This prompt will be given to the LLM, which is DeepSeek in this case. To give you an idea about the prompt, we say context information is below. The context will be the relevant documents to answer to the question. and we say to the model, given the context information, which is this one, I want you to think step by step to answer the query, and so on. And after that, we give the query, which will be the user query, and the model will give the answer based on that. We pass this prompt template into our query engine, and we query the engine using this question in this case. And this is exactly what is happening here. Given the user query, this query is embedded as well with the same embedding model used to embed the documents. This is very important, guys. It should be the same model to embed the query and the documents. Once the query is embedded, it's used to return the most relevant documents. This is passed to the prompt. The context will be the relevant documents. The query will be in the prompt as well. The whole prompt will be given to the model, which is DeepSeek in this case, and the model returns the final answer based on the query and the context. So this is the whole pipeline running behind the scenes. So all this is documented in an interesting tutorial on lightning.ai. I will put the link to the tutorial in the video description. You can try all this out, guys, in a notebook on Lightning AI Studio. You just need to click on Open in Studio. Once it's done, you will have all what you need in Lightning.ai environment. When you create an account, guys, you will see that you will be asked what environment are you used to. For example, I answered VS Code, and as you see, it's similar to VS Code, but you will see all this when you create an account. So here you have the main notebook that contains different parts that I've presented so far. You just need to run the cells, importing libraries. Here is going to be the directory which contains your files. In our case, it was the PDF file. We import the model and the embedding model. We define the loader, we load data, create the vector store, create it as a query engine. This is the prompt template, and we query the vector store using the same query. And here we have the answer. Now, to show all this using Streamlit, you just need to click on Streamlit icon here. You create a new app. You choose the file that contains our app, which is app.py here, and you run the app. Here is our app up and running. We browse files again, the same file that you used in the beginning. The file is indexed and the model is ready to chat. So this is it, guys, for today. In this video, I showed you how to create a search app that you can run locally thanks to Ollama, and for free thanks to open source models like DeepSeek. This was a basic search app based on RAG, but this can be improved using re-rankers, for example, to re-rank returned documents to answer a query. Different chunking methods can be used as well. Different embeddings can be experimented, and all different parts in the RAG pipeline can be improved to have better results. Don't hesitate, guys, if you have any questions related to this pipeline, you can ask them in the video description, and see you next time.